And in the next chapter, we're going to talk about fire. As you can see, I switched to version 18 because for now it's a newest version, and there is some new features in Pyro. So with the smoke we did last time, mainly we stay in the same. But when we work with fire, there is some interesting new features we haven't within 18. So we have a sparse, we have some flame setup. So I will start with the basic setup for the fire, and then we will talk a little about new features. What is important here is that we can decrease our container size using the sparse mode. So we will talk about this later. So now, what is the fire? Like we did with the smoke, the first thing we want to add here is a source. So let's say just simple geo, call it source, and we'll make a sphere. I guess it's the best setup we can use here because the simple way to understand the fire. Maybe I just want to rescale a bit and make it a bit smaller, like maybe 0.25, and make it up a bit, maybe like 0.26, just a little bit about the surface. And like we use the smoke, like we create a smoke, the first thing we want to do is create the pyro source. So let's go here, and I just add a simple pyro source. I will use the surface scatter to add some points on the surface for this sphere, and maybe decrease the particle separation to add a little bit more particles, or even more here, like 2025. Should fine. Let's look fine. Now, what I want to create here. So last time when we add a source for the density for our smoke, we create a density shell or create a density field. Now for these particles, I want to add a fuel. So what is the difference between the density and the fuel? In fact, when we create a smoke, we use the density and the temperature to create the advection for our smoke. So we have like two different fields, and they work together. The density shows us the density of our smoke, and the temperature can create an advection to create some movement for our smoke simulation. When we create a fire, we're using the combustion model. And how this model works, I can show you. Can go to my paint. So as in always, we have some source, and this source can be any object we want. We add some particles on this source to get the particle attributes, and then convert those attributes into the fields. So the first thing, we create the field called fuel. Okay, so the combustion model tries to create the same thing we have in real life. In real life, if you want to create a fire, we need something which we want to burn, and that we can call a fuel. It can be wood, coal, oil, anything we want to burn. Then we need to add an ignition. We need to ignite this fuel. So we need to add some temperature, very high temperature, on this object to get a fire, because by themselves this fuel will not ignite. We need to have some influence on this fuel, and this influence is the high temperature. After that, we have an ignition. In our case, we create the field, call it burn field. So we can create like this orange color. So the fuel which we ignite with our temperature, we transfer to the burn field. So in many cases, the burn field will be the same like a fuel. But when we're going to talk about combustion model, we will see that not all fuel will transfer to the burn field. The thing is, sometimes we don't want to ignite the all amount of fuel. Maybe we will ignite just 90% by default, and we keep 10% of fuel without ignition. So burn field, mainly you will see it looking like a fuel, but just this part of the fuel we will ignite using the combustion model. Then our burn field will transfer to our heat field. So basically this heat field is our fire. Using the temperature, this field will create flames, okay, from our fuel. And then we will transfer this heat field into the smoke. So when this heat, the temperature of our heat field will begin to smaller and smaller, and it will transfer to the density field. All right, so that should be our density. So this combustion models works in Houdini many years, and it works fine because now we can simply understand how we can create fire with different settings using the big amount of different fields settings. And it's pretty the same like we had in the real world, but yeah, without any fields, of course, but the main technique is the same. All right, so what we need to have, in fact, we have a fuel, and we can add the temperature field, because as you understand from this nice high detail picture, we need to have a temperature for ignition. So, and for some advection on top of this. So I add fuel and temperature. Now we have those two attributes. And as always, we will send all those attributes into the volume rasterize. Volume rasterize attribute, the same node like for the smoke, and here fuel, temperature. Okay. Like here, we can normalize, we can decrease the voxel size, I guess, because we have a very big voxels, maybe even smaller. Anyway, we can choose the particles, can remove the coverage attribute. Now, let's create a fire, now without any noise for this moment. Let's add a null object, and we create the output. So it's going to be my fuel out. Very simple for now, I hope. Now, what I want to do here, I want to create a dope network. So that's going to be my, let's call it fire source. And let's call this fire sim. And check that, oh, we can leave it to have an idea where I want to put my container. Now go to the pyro solver. Smoke object. So there's all stuff like we did with the smoke, nothing changing. And a volume source, connect it here, select my sourcing. Oops. It's my fire source, fuel out. Now I want to choose from initialize the fuel source fuel mode. Okay, so now I want to drag this container about the surface. Maybe like here. I should find, now decrease the number of voxels, and as always, I want to copy this parameter and paste relative reference for my volume rasterize. They should work together. Okay, now let's switch and set solvent creation frame and press play. There is nothing for this moment. If you look here, we have a fuel and we have a temperature and we have velocity, so we can just click here to cancel my velocity import. There's no velocity. And we don't have a density for now. Let's go here to set up my smoke object. Why we don't see anything? If we look on our temperature, we have something inside of here. And we have some fuel if we turn on this field, and we have a heat. So there's something like a fire we have here, but we can't see inside of our container because we look on the density. And density, as you know, is a smoke. But this smoke, if we create this smoke from my fire, there is our fuel should go into the burn, into the heat, and then when it cool down, it will transfer to density. So the thing is, there is not too many smoke for now, and we can't see the smoke basically. So to see the fire, I want to use the multi-field except of the density. So go to multi-tab. For the smoke, as in always, we will choose a density. We can copy this to diffuse field because they should be the same. And with an emission, I want to work with heat as an emission field, or we can use a temperature for emission field, and we can use a heat field for the color field. So now we can see something looking like a fire and even some smoke, I guess. This white should be a smoke. No? Anyway, we can see this fire, but it's very low res. If you look on our container, it contains just from 100,000 voxels, so there's not too many. And I should add the gas resize because I want to increase my container size. So I check max bounce, density, and I want to add a heat field because the fire should create the bigger container. So now it's not looking like a fire for now, but we can see that something going on here. Something we see. We see the fire, this orange color, the yellow transition to orange. That's fire what we create now. So yeah, there is a lot of work now with this fire, but in fact we have something here, and that's how our default fire looks. All right. So now what we have here, when we look at our temperature, we can see just from this side that we have a huge temperature inside of our simulation. We can go here and look the maximum and minimum range of our temperature. I have a lot of questions how to look on the temperature settings inside of our simulation, because we're not playing with kelvins or Celsius, we work with just numbers. So now we can see that if I put here maximum number is 5, it means that those areas with the white colors have the maximum range is 5. So when you work with shader, you can definitely use these guides to look on the higher and lowest temperature inside of your simulation. So if you say press 1, it will cut all those areas which have the temperature less than 1. So it's just for visualization, but you can definitely use this setting to get the minimum and maximum value to set up your shader as an option. But in this case, we can see how this temperature increasing and decreasing. We have a very small amount and the higher amount of temperature here. And we can see the fuel. And by default, our fuel will not go anywhere, because it stays this position. It will not be advected by default. I will show you an option how we can do this, but by default, our fuel will stay at the same position as we have a sphere. Now the next field is a burn. And again, if we compare those two fields, they look like the same, but burn field include just that part of the fuel field which have to be ignited. So we have some settings inside of PyroSolar, I will show you that. And the heat field is actually a flame of our fire. And when our fire begin to cooler and cooler, we will create a smoke. So now we can see a density field from this position. We have some areas which will cool down to very low temperature, and we will transfer information from the heat field to the density. The amount of density and transition settings, again, we will set inside of PyroSolar. So it's always very good to use this multi-field visualization. We can increase the emission rate, but this is just a visualizing of our process. It doesn't change anything inside of our simulation, just for visualization. But it's very important to understand that if you want to see your fire, you need to have the multi-field enabled, because we want to see in different fields, on a temperature, on a heat field, the density, etc. So now let's go and we will see what we have inside of our PyroSolver. So by default, again, with the volume source, we use the same setup as for the smoke, just except of density. We have a fuel and we transfer our source into the fuel field, and we have a temperature. So we can play with the scale here, we can play with operation if you want to use like a maximum, maybe sometimes it's useful, or you can play with a higher temperature and it will have a good influence on your simulation. So basically not too many changes inside of volume source, and not too many changes inside of our gas or size fluid dynamic. You just need to keep in mind that we need to add another reference field if you have just a fire, because in our first stage you can see that we don't have a density, so just small part of the density we have. So to help our gas fluid dynamic node more accurately create container around our simulation, I'm gonna put a heat field as a reference field. Sometimes when you create a fire without any kind of smoke, we need to remove our density and put a heat field here to have a reference from the heat from our fire. And again, with the smoke object, we just use the multi-field except for the density. All right, so it's like main setup for our fire. And now let's go to the PyroSolver. We will see how we can change our fire to have a more accurate and more realistic results.